Hello and welcome to this presentation from ICAEW. My name is David Lyford-Smith. I'm a technical manager in the tech faculty and I run ICAEW's Excel community. I'm going to be speaking for my EuSpRIG presentation for 2020 in this video, and I'm going to be talking about some comparison of some commonly used tools for different Excel purposes and how they stack up in terms of robustness, likelihood of error, just generally how they compare and contrast, and trying to show, I hope, that there really isn't any one best method for solving problems, but instead that it's dependent on context. The particular example that I'm going to be using is 3 templates which I've built for doing sampling. So if you're familiar with this as an audit practice, essentially it's just about picking up random items to check from a list. And the 3 templates I've built all use the same data set, which is 100 items labeled 001 to 100, each with a monetary amount. And the aim of the template is that we can choose the size of how many items we want to include in our sample, and we can also choose between 2 different sampling methods. So in the first method, which I've called item sampling, we're just literally picking items at random. So if, for example, we want 10 items, we just pick 10 items out of the 100 at random. Each item is equally likely to be chosen. The second type of sampling, which I call monetary sampling or monetary unit sampling as it's often known, uses a more sophisticated method which is weighted towards the larger value items in our list. So if we imagine that these are transactions, I'm probably more interested in spot checking this £9,000 item than I am this £116 item, because this one is significantly more likely to affect my overall total. So the way that monetary unit sampling is done is that we look at the total value of items. There are £535,000 worth of items, and we pick £10 within that range at random and check where they fall. So if we think we have our cumulative value here, if, for example, we decide to randomly check the 100,000th pound, then we can see that falls somewhere in item 18, this being the total of items previous to this row. So if you see, if I total up these items, it's just over 100,000. So the 100,000th pound is one of the ones in item 18, and so that would be our sample. Monetary unit sampling can lead to duplicates, and I'll also compare how the 3 different methods cope with trying to avoid picking the same item more than once. And I'm going to, in this presentation, both show how these 3 templates work. One uses standard traditional Excel formulas, one uses dynamic arrays to do it, and the third one uses VBA macros to do it. And I'm going to talk about both how these work, and then also compare the kind of strengths and weaknesses of each approach, and why none of them is a all-around perfect solution. So that's a little bit of an introduction. I'm going to get started now with the standard formulas template. Okay, so let's start by looking at the standard formulas template. So this just uses ordinary traditional Excel formulas and tables. It doesn't use any dynamic arrays or macros, as those are going to be used in the other 2 examples. I've used cell styles to format the various different calculations here. So you'll see that the sampling type is a drop-down that allows for the 2 sampling types to be chosen from. But in this case, the size of the sample is actually a calculation. It's not something that the user can set directly. And that is because we're using Excel tables to pick items. So first of all, let's talk about the data. The user is able to copy their own data into these 2 columns here with an identifier for each as well as the value. And then the rest of this table, which is called sampling, is just some helper columns to help out with the calculations we're going to do later. I've numbered each of the items just for ease of reference. This isn't absolutely necessary, but it's just helpful for further calculating and keeping an eye on things. That's just with a row function at the moment. The cumulative value and the randomizer are helpers which we're going to use for the 2 different types of sampling. So first of all, let's talk about the item sampling. So this is where we just want to pick 10 or however many of the items completely at random, so each has an exactly equal chance of being chosen. This has been done by including a rand formula in our table, Because this is an Excel table, it will automatically copy the formulas onto the number of rows as the user creates more or fewer rows. It will automatically include this formula here. Rand is a randomization function that picks a random number between 0 and 1. There's 15 decimal places of accuracy available in Excel in terms of how large of a number it stores. So there's statistically no chance of duplicates showing up here. And that's going to drive how we actually then pick our items. So what we see over on the right here is this is our sample table. This is another table. This one is called picked. And this is all formulas. And this is how the user can decide how many items they'd like in their sample by deciding how big this table is. So one of the disadvantages of traditional Excel formulas is that we have to do things like this. If we want to vary the size of our items, then the user will have to manually resize the table. The formulas will copy automatically if they expand it, but there still has to be some manual element there. And if they want to shrink it, they'll have to delete extra cells as well. So it's a little bit annoying. So we've got, first of all, just a row function that numbers each of our items. That just helps the user keep a track of how many items they've included in their sample. And now our identifier formula. Now this is pretty lengthy as far as formulas go. However, it's actually both of our formulas, because what we've got here is a question that uses an if here. So it's an index that is going to choose something from the item identifier column, but we have got an if here that provides two different methods of doing that. So if we just look at the value if true element, that is what is being used when we're doing this item by item sampling. So what we're doing is we're doing a match, and we're using the large function. So large is going to pick the nth largest item, and this is actually where we are also leveraging our item number here. So we're choosing the 1th largest, the largest item in the random range, and we're matching that against the whole range. So that is going to identify the position at which the largest random number is found, and that number is then going to be fed into the index. And so that means that the largest random number, that's the first item we're going to pick. The next row, well, that's going to be using large with a k of 2. That means that the second largest item is going to be chosen instead. So the second largest random number is going to be chosen, and then the third, and the fourth, and the fifth, and the sixth, and so on. And as I mentioned, because the rand functions have 15 decimal places, there's no chance of duplicates showing up here. There's just not enough different values for that to be at all statistically possible. There's 10 to the 15 different possible options here, so we don't have to worry about duplicates, and we just get our items chosen. So that's a pretty straightforward one, and as you can see, that's the shorter of the formulas here. The other one, monetary unit sampling, let's switch it over to see what that actually looks like. Now, first of all, we'll see we've got a warning appearing here. Monetary sampling can lead to duplicate items being selected. And if I recalculate with F9 a few times, you'll see that there we go. In fact, 2 duplicates have actually shown up here, and another warning is telling me that duplicates are present. That is one of the other constraints that we're going to have to think about when we get to comparing the different approaches. But let's actually talk about how this works. So we're making use of a cumulative value here. So we are tracking the total cumulative amount that has been encountered in the table thus far. And it's actually counting the amount that has been encountered prior to this row. So you'll see our count starts at 0. So the way that calculation is done is using a sum and an index. One of the nice things about the index function is that it can be used as one end, or indeed both ends if you want, of a range. And that means that we can do a simple single formula that will do a kind of counting total. So here we are saying that our sum range starts at indexing the value column in the first position. So that will return a reference to the first item in the value column. And then it's going to finish at the at value, so that is the current value column, so the current row position. What that actually means, if we step into the calculation and watch it calculate, we look at that value column, we take the first value, that gets us a cell E11, we then look at the value column that matches the row of the formula, of course that's also E11, so we then add up our range here to get our total. And because we want to only count what's happened prior to this row, we're then going to subtract that number from the row, and that of course gives us 0. But if we look at the next row, in fact, let's go down a couple more and look at this one. So here, once again, we're getting our index that's going to get us E11. That value now represents E13, so we have our range of E11 to E13, which we can then sum. That gives us our total of all 3 rows. We want to subtract what's on the current row to give us the total from the 2 prior rows. And that's a nice, reliable way of getting our cumulative total. Now, what's that cumulative total actually used for? Well, it's used because if we have a look at our if function here, let's actually do it in the taskbar, the value is false. So we're once again indexing the identifier column, but here we're doing it, because we're using monetary unit sampling, we're going down the value of false fork. And what we're matching has changed. We are matching a rand between value, a random value that is between 1 and a round down that's rounding down the total value. So there's £535,329.15 here. We're rounding that down to the nearest pound, so 535,329. That will generate us a random number between 1 and 535,329, and we're then doing a type 1 match, which is, as you can see here, is a greater than match. But it's going to look for the last value that is not greater than the search. So that's a little bit of a complicated concept, so let's break it down. So let's just say, for example, that our randomization function returns 500. The match is going to look at the cumulative value here and say, well, 0, that's less than 500, but the next item goes past 500, so we're going to return a match of 1, saying that that's the last item that is less than the search value. And that's why we're subtracting the value out of our cumulatives here, so that everything is lined up properly. So, for example, if we were to get 535,329, very unlikely, the last pound, then that blasts past all of the items, so we're going to get a return value of 100, and we're going to be pulling the last item in the list. Now, that rand between, of course, definitely, again, with 500,000 items, different rand betweens that each of these 10 values are using aren't likely to be the same, but there's nothing that can prevent individual rand betweens picking 2 different pounds that are within the same interval and refer to the same item. So it is possible that these functions, because they don't look at each other, can pick the same item. And with basic Excel formulas alone, we can't really avoid that. So of course, that's why we've taken these steps to say that, it's possible that duplicates might show up depending on how large the sample is. It might not be that likely. It might be quite easy. In this case, I can just refresh it once and I immediately hit it in a case where there are no duplicates, so it's not that bad. But if I was picking a significantly larger number of items, thanks to the birthday paradox and statistical problem, I'm now much more likely to hit duplicates. And in fact, with 21 items here, you can see that basically every time I generate a random list, I'm seeing some number of duplicates. But even though I've got a sample size of nominally 21, realistically, I'm actually pulling less than that. And that's one of the inherent limitations. But that's how this actually works. The value is then just an index match, which pulls out the corresponding value based on the identifier. So let's just take a moment to review the advantages and disadvantages of using traditional Excel formulas for this case, just in general. Firstly, because we're using Excel tables as our principal part of our continuity, you can see if I shrink the items, I have to delete things. If I want to pick more items, I have to copy more. Even though it's just a matter of dragging the corner of the table, it's not a particularly difficult thing to do. It's still adding a manual step. Secondly, when we're doing our monetary unit sampling, we don't really have a way of avoiding the fact that we're occasionally going to get these clashes of the same item, and that's because these items are independent. Each of these calculations is happening independently of the others, and so we can't check for things like that. But on the plus side, because this is all made with traditional formulas, it's very interoperable. It can be used on any version of Excel. It's much easier for anybody to pick up and review because it just uses familiar formula syntax. This, obviously this is a big complicated formula, but you could use something like evaluate formula to step through and see, how is this working? Oh, okay, so we're doing this, and then we're going down this line. Okay, so then you can watch this bit by bit, and you can see how the calculation is done, and that means that it's much easier to both understand and correct, but also to troubleshoot if something goes wrong. So it's much more accessible, but it does have some clunky facts, which, with things like the duplication and the sort of more manual nature of it. So next we're going to compare the same task, but done with dynamic arrays instead, and we'll see how that compares. Okay, so for the second part, we're going to be having a look at solving the exact same problem with the exact same parameters, but this time using not traditional formulas, but instead dynamic arrays. So dynamic array formulas were added to the Excel Insider program and then rolled out to the rest of Microsoft 365 over the course of the first half of 2020 or so, and they're now available in essentially all Microsoft 365 versions, but they are not available in Excel 2019 or any of the other mainline Excel releases, only in Microsoft 365. And that does mean that when we are talking about the comparative advantages and disadvantages, this approach immediately comes with a big hampering factor that it's only workable for people who have access to those versions. So that's something we're definitely going to have to think about when we're weighing up the advantages and disadvantages. It's just less widely usable. But it does have some significant advantages as well. As with the previous example, I'm going to show you how this is actually accomplished, technically speaking, and then we'll look at the advantages and disadvantages from there. So we're using the exact same example with 100 items, same values as last time. You'll note that this time there's no randomizer column, but I have kept that cumulative value in there because that's still useful for when we get some of the monetary unitary sampling later. As before, we have a drop-down where the user can choose between the two different sampling types, but this time the size of the sample isn't set by some clicking and dragging of a table. It's instead a cell input, and you can change that input to change the size of the sample. In terms of the actual formulas that we're using here, the first of them is our very first dynamic array that we're going to be looking at, which is the sequence function. This is a very fundamental dynamic array function that just returns an array of a given size. So in this case, we've chosen to point that at the size sample there, B3, and that returns in this case, 10-row sequence. You can change the starting point of the sequence and the step, but it defaults to counting up from 10. And that spills into all of these further cells. If you're not familiar with the behavior, you can see the formula in gray in the bar, but these values are actually all consequences of this single formula in H3. We then have our main identifier, and in fact, if you see in the formula bar here, this is obviously a much longer formula, but it's fundamentally still the same structure as before. We're using an if function that checks whether or not item sampling has been picked. If it has been, we have this quite modest formula for doing our sampling, and if not, we have this more complicated one for doing the monetary unit sampling. But again, I'm going to talk about each of those individually and sort of show you how they're built up. Once again, this table is called sampling. So first of all, let's talk about the item sampling. So this is where we just want to pick, in this case, 10 items completely at random. First of all, we can just point at the sampling item identifier column using our structured references, and that automatically returns an array of all 100 items in the order that they appear in the table. So that's where our formula starts, is by getting all of those numbers. The second part of it is creating an array of random numbers of equal size. So for that, we are going to use the randarray function. This fills an array of whatever size we specify with random numbers. In our case, we are going to set the number of rows based on how many rows appear in our sampling table. That will produce an array of 100 random numbers, and it uses the same basis as the rand function. So again, 15 decimal places, and just like before, we don't have to worry about duplicates. What we now want to do is we want to sort the items in this array according to a random array. So the way that we're going to do that is not having a rand array in a separate column, of course, but instead we're going to step into our function here, and we're going to use the sort by function. This is another one of our dynamic array functions, and it allows us to sort one array according to another. And that can be used for sorting tables into order by one of the columns in that table. That's really what it's mostly used for. But we can also use it for randomization by creating a random array, which is the same size as our chosen list, and then sorting this list by the random list, which of course effectively shuffles our list of 100 items into a random order. There we go, there's our random order. It is volatile, so if I recalc, you'll see that the random order changes. Now, finally, we just need to restrict that. We don't want all 100 items, we only want the given value of items. So if we only wanted the first item on this list, one way that we could do that would be to use an index function, and we would index that number 1. I'm going to pull that out of H3 there, and that would pull the first item from that randomized list. And we can imagine we might want to repeat that formula for the rest of these values, but this is where we can take advantage of the other thing that we have in dynamic arrays, as well as these functions. We also have hash referencing. H3 hash is a reference not to H3, but to the dynamic spilled array that starts in H3, so that whole sequence function. And as that changes in size, this will also change in size. That means we get our 10 random items, or if I change this to, let's say, 15, we get 15 random items. That's how that first function works that's inside here. Now let's talk about the second part, which is how we're doing our monetary unit sampling. You can see this is a bit more complicated, but again, I'm going to build it up step by step to show you how that works. So the first step is to generate a list of all the pounds. So there are 535,000 pounds represented in our sample. I want to generate a list of each of them in order. Again, that's a sequence function. I can just point it at this cell where I've calculated the total value. You don't have to worry about the extra 15 pence here. That's just ignored. And you can see there is a sequence function stretching out 535,000 rows. It's very, very big at the minute. We are actually going to be randomizing that in exactly the same way that we did before. So we're going to use our round array and our sort by to do that. So it's exactly the same thing again, generating a random array of just the same size and sorting by it. That will sort our pound amounts from 535 to 3291 to a random order, which we see here. But of course, we've now got 535,000 of these. So we now need to take this a step further. We now need to associate each of these items with the item identifier that it falls into. And this is where we're going to do our index matching, just like we did with traditional formulas. We're going to index the item identifier column of our table by matching the result of the sort by, so matching, and it will match each item in turn. Because of how dynamic arrays work, we can put a whole array into this lookup value, and it will carry out this item, the index match for each item in turn. And of course, we're looking those up in our cumulative value, and just like before, we're using our if1 or less than sort to do that. So close both of those brackets. Give Excel a second to calculate those 500,000 index matches, and that means that each of those random pound amounts is now associated with its with the appropriate item identifier in order. Now, the next thing we need to do, of course, this is still 500,000 items long, and it contains loads and loads of duplicates. It contains nothing but duplicates and plenty of them. However, we can easily fix that by passing this whole thing into a unique function. So we're going to look at that, and the unique function, this is another dynamic array. It will take this array and strip out the duplicates, leaving each item to appear only once. And once we've done that, we see we now have a 100 item array, and the order here is the same order that the items first appeared in that longer list. So the order hasn't been changed, just the same as the traditional remove duplicates. The items that appeared earlier are towards the top. The items that appear later are at the bottom. And that means that we've successfully weighted our sample towards the higher items, the sort of larger values, because they're more likely to show up earlier, but we aren't going to have to worry about duplicates. You'll see, in fact, actually the last few items here, 5, 56, 84. These are, 84 is very small. 56 is pretty small. 5 is actually the smallest one in the whole thing. So it is working. You know, those items are less likely to show up earlier. They're going to be further down the list. It's unlikely that we'll see them at the top. Finally, we need to restrict this to be only the sample size that the user has indicated. Same trick as before. We're going to index that whole thing according to a reference to our sequence function, and that will then return the first 10 items from our list, and that then gives us our monetary unit sample. And of course, the values here are just an index match, taking advantage of the hash referencing once again to look up each of the items in this spilled array using that hash referencing before. And that means that, again, we can say, actually, I want 20 items instead, and it will pick 20 items for us. Or I can say that I want to switch over to monetary unit sampling. And if I do that, you'll see that my items get a bit bigger. They're not 100% guaranteed to be bigger. This £474 one still has a chance of being chosen, but we are skewing towards the larger items. We're weighting our sample towards the more beefy items in that list. So dynamic arrays has, of course, we mentioned that disadvantage of interoperability and accessibility. It's less widely usable by different people because of the fact it's very, very new and less well understood. But it does have the advantage that we don't have to worry about duplicates for our monetary unit sampling. We can take care of that. We can make it much easier to change the sample size and not worry that the user is going to accidentally not do that correctly, not copy formulas correctly. It will just work. So that's definitely an advantage. We also have just generally a much simpler time of producing this. This is just 3 formulas and it just kind of works. We don't have to worry about the table thing at all. So it's a bit more robust. I think it's got a lot of advantages, but the big disadvantage, of course, is that accessibility, is the fact that this is so different. It does share the disadvantage that we are still producing a volatile list here. So if I wanted to go and actually sample these items, I couldn't leave these as were. I'd have to copy them and paste values so that they'd stop constantly changing. So that's certainly a disadvantage. But overall, I think this is a pretty neat approach, and I'm interested to see how dynamic arrays, as they become more widely available, change the way that things are done in Excel. But that's a look at how that works. What we're going to move on to next and finally is a look at performing the same task using VBA. So for this last part of the presentation, we're going to be looking once again at the same example as before, the same situation, same types of sampling, same data, but this time we're going to be having a look at doing it using VBA instead of formulas. So obviously VBA has been around for a very long time. In fact, it's sort of semi-deprecated by Microsoft now. They're moving into Office scripts and aren't really supporting or updating VBA anymore, but it's still very much available. As with the other 2 examples, I'm going to walk through how this actually works, talk a little bit about the technical implementation of it, and sort of show you it in practice, and then talk about the sort of pluses and minuses. So we've got a couple of buttons now, so we can say select sample. You get a simple pop-up, just enter 1 for unit sampling or 2 for monetary unit sampling. So let's do 1 for unit sampling. Define sample size, let's say 10. And the VBA then fills in very quickly the appropriate identifiers. So we can see that it's filled in, for example, 23, that has a value of 883341. Yep, that matches, and that's all kind of worked. We also have a button that says clear current sample that clears the thing down so that we can use it again. Let's just go with monetary unit sampling this time. Let's say that I want to have, I'm actually going to do the full 100 items. It's going to take a little while to do that because of the way that this works, but once it's all done, you see we have exactly the total value sample is 100%. We have all the items, and as you might expect, if we come down to the bottom here, the last few are the smallest items in the list. So once again, we can clear that sample. So let's have a look at how that's actually done in the background. I'm going to go into slightly less detail about this than the others, just because it's a little bit more involved. So we have a small subroutine, first of all, called start, that first of all just uses an input box to decide what type of sampling we want, and then based on the result of that, calls either the unit sampling sub or the monetary sampling sub. So those are in separate ones, and there's just a bit of error checking there in case they enter something else to give an error box if they don't do that. So let's have a look at how unit sampling works. So this is where we actually now ask the user for the sample size. We have a quick bit of error catching here where If the user asks for a sample size that is larger than the number of rows in the sample, we give them an error message and exit out of the sub, so making sure that we don't end up in that situation. We then set up a few different variables here: sample array, new candidate, and repeat. And this is where we then enter a loop where we're going to be actually picking our examples. We do also want to make sure that we are going to check that these examples are unique. You'll see that sample array is a collection. So what we've done here is set up a do while loop. So we're going to check, so for as long as the sample array count is less than the sample size, so we haven't yet reached the necessary size, we're going to set repeat, which is a Boolean flag, to false, and then make a new candidate. So this uses a worksheet function ran between, so we're just going to make a random number. So if we, at the end of that, we've got our candidate. If our array count is 0, we don't have to worry about duplicates. Otherwise, we can move into this loop. So this loop is just checking that we don't have a repeat. We're just going to go through a variable from 1 up till this number of items in the sample array and check whether or not we have that number. You'll notice we're just dealing with numbers at this point. We're just making our list of random numbers. We aren't actually associating them with values. So we're just going to check if that item already appears. If it does already appear, then we're going to set the repeat flag to true. And if it doesn't, we're just going to move on to the next J. So we're going to check each item. At the end of that loop, if we have set our repeat flag to true, then we know that we have a repeated item. So at the end of all of this looping, if we have got a repeat, we don't do anything. But if it's not a repeat, we add our new candidate to our array, we end our if, and we loop again. So we've checked that that item is not already in our collection. If it is not, we add it to the collection, and then we loop, and we keep doing that until we have a long enough list of items. Once the loop is done, we then output by looping through the array and using our table. So we've got our table here. We've used the table again just for convenience for reference, and we're offsetting down that table based on how far through the array we are. We're using indexes to pull the appropriate identifiers and values. So we're just going to essentially print out the list of items based on our random numbers. Monoseries sampling, pretty similar for the first part. Again, we're just checking that the sample size isn't excessive. We are also going to set up our monetary size number here. This is where we're actually going to find out how many pounds we have. So we're using our sampling value item. So we're going to add up our sampling value column. So here we can see what our total item is. And then we've got a very similar loop where once again, we're going to set a repeat flag. We first of all make our new candidate into a random pound, so between 1 and the monetary size, but we then map that onto the specific item. So this is using the index match with match type of 1. That's very slightly off the end here. Match type 1 again. So we're going to map that item into a specific item. And then we're going to add that item. This is actually, of course, looking at the item number. So we're going to add that item number to our array if it isn't a repeat. So we're checking for repeats in the exact same way as before, but we're doing it using the item numbers rather than anything else. And we're doing that by mapping our random numbers onto the items here. So that achieves the goal of monetary sampling. All of the rest of this is exactly the same as before. And then there is also a little sub here which will shrink the table down to nothing if we need to at the end, so that we can clear up our table. So it's just these subs. They're all relatively short, not too complicated. Well, depends on how you measure complexity of these things. Of course, it all works as before. It shares with dynamic arrays that we don't have to worry about duplicates. In terms of disadvantages, though, of course, VBA comes with a pretty hefty cost in terms of opacity. Most users can't interpret VBA code, might not even know how to get to where it's stored, so they don't necessarily know how this works. That also means that, as well as being harder for the user to kind of verify and check, if it's behaving funny, if it develops a problem, if it needs updating and maintaining, then a much smaller percentage of the users are going to be able to do that because of the fact that it's all in VBA rather than in formulas. So it's both hidden and harder to work with. There's also, in terms of disadvantages, VBA has the problem that not all computers will accept it. If you are working on a secure environment, for example, you might not be able to download .xlsm files or might not be allowed to run macros from unknown sources. So this, for security reasons, might be blocked in various places as well. It does, in terms of advantages, share with dynamic arrays. We don't have to worry about duplicates. That's taken care of. It's very, very simple to run. There's no dragging of anything like we saw with the traditional formulas approach. It's just based on buttons. But there are still those kind of complexity and accessibility issues, which I think are a disadvantage as well. So in terms of avoiding errors, I think that the latter two approaches that we've looked at, dynamic arrays and VBA, are better at avoiding duplicates, avoiding user error, but they also add complexity and reduce the ability of the user to understand and interoperate and work with the template in a more advanced way. So there are trade-offs, and that is ultimately what this is about. There are multiple ways of solving pretty much every problem in Excel, but those ways are not equal, and there's not a best solution for every situation. If you wanted to make something that was easy to use and reliable, what that means changes depending on who is using it and what they know. If you know that you have reasonably educated users that are using 365, I would probably use dynamic arrays because I think that's the most kind of flexible and easy to use solution. If you want to make something that is as simple as possible and you know that the end users aren't going to need to ever interact with it or update it or understand how it works, I'd probably use VBA. If I wanted to make something that was followable and learnable from, and which was easy to demonstrate why and how it worked and was easier to review and verify, then I'd be using traditional formulas. It depends. And I think that too often people who make these kinds of solutions default to the solution that they like the best, the one that they find them is the most comfortable, rather than thinking about what's actually the best type of solution for their use case, for their users, and what's going to, considering the risk profile and the kind of type of use case that they're looking at, what's going to be best. So that's a little bit of a look at these three different templates, different ways that they might be done, and the kind of strengths and weaknesses of each approach. Hopefully you found that useful and interesting, and there will be a link where you can access these templates in the description of the video if you'd like to download them and have a look for yourself. All of them also include a binomial statistics calculator as well, if you're interested in looking at that. But there's lots of different things to play around with in each of them. Thank you very much for watching. Once again, I have been David Lyford-Smith of ICAEW, and I hope you have a very good day.